Hello, General Chemistry. Today we will be looking at Lewis dot structures. And we're going to be looking at only Lewis dot structures for simple single atoms. Now, a Lewis dot structure has some pretty useful tools. It's a pretty useful tool. It can be used to predict how many bonds a single atom can make, how many covalent bonds, and how it would, how it will connect to other atoms. And so when we get to the molecular side of this, we'll explore that. But for now, we just want to see what is a Lewis dot structure? Well, it kind of communicates the valence electrons of an atom. So if you know the valence electrons of the atom, you follow a few rules, you can make a Lewis dot structure. So we're going to illustrate that with lithium here. Lithium is an alkali metal. It is in that first column, so it has one valence electron. So we are just going to put one valence electron right on the top of lithium. That is our Lewis dot structure for lithium. Lithium's easy because it has one valence electron. Now we're going to go to magnesium. Magnesium, an alkali earth metal, has two valence electrons. So there's some rules for when you place multiple electrons. We tend to start at the top, and then you fill sides, but you avoid doubling up if you can. Since we can put one on the top and one on the side, we're fine. We are done doubling up. We don't have to double up to fill in two. Now, boron is three valence electrons. So let's do boron here. All right. Well, we can put one on the top, one valence electron, one on the side, and let's go one on the bottom. We'll go clockwise. So this is boron. Boron has three valence electrons, and they're arrayed as such. Now let's do fluorine. Fluorine is a different story. Fluorine is a halogen. Fluorine has 7 valence electrons, so it's going to get a little busy here. We can put one on the top, then we fill the sides without doubling up. Well, I can put one on this side without doubling up. I can put one on the bottom without doubling up. I can put one on the other side without doubling up. And at this point, we need 3 more. We have to double up. So now we can put this here. And this is now paired electrons. They are paired because there's 2 on a side, and that's what pair is. So let's take a look. We're going to review a little bit about paired and unpaired electrons. Lithium has 1 unpaired electron. Magnesium has 2 unpaired electrons. Boron has 3 unpaired electrons. But fluorine only has 1 unpaired electron. Even though it has 7 valence electrons, it only has 1 unpaired electron. The number of unpaired electrons is going to be useful when we start predicting how these atoms come together in covalent bonds. So that number matters. The number of unpaired electrons matters. Let's move on to oxygen, which has 6 valence electrons. So, like fluorine, we're going to get all of the sides filled up. And then we're going to go back and double up some of the sides. So we'll double up the top, and let's double up. We can double up the bottom. That's fine too. So now oxygen has 2 unpaired electrons. So fluorine has 7 valence electrons and 1 unpaired electron. Lithium only has 1 valence electron, and it is also unpaired. So both of these have 1 unpaired electron. These have 2 unpaired electrons. Now let's take a look at nitrogen. Nitrogen has 5 total valence electrons. 1, 2, 3, 4, 5 total valence electrons. How many unpaired does it have? Well, just like boron, it has 3 unpaired electrons. We're going to talk more about what the significance of those unpaired electrons are in our next video, but we're going to keep going with our last single atom, carbon. Carbon has 4 valence electrons, so we're going to just fill in each side. 2, 3, 4. That's it for carbon. That's it for single atom valence electrons. That is all there is to it. Find the single atom Lewis dot structures. Find the valence electrons, fill them in, try not to double up on each side, but if you have to, then you got to go back and have to. I hope this helps. Struggle well.